Hello, everybody. This is Sean Crawley and Jake Nelson. We are part of the Civil Engineering 594 Geospatial Software Engineering class with Dr. Ames. And we're going to be explaining to you a project that we did using ArcMap and Python. So the background of this project, it's called the Temple Locator, and the LDS Church is often building new temples and wanting to build new temples near their membership where the current members live. And we wanted to build a script that for the US can take states that do not currently have a temple and run some geoprocessing to optimize and pinpoint locations where a temple would be possible and optimal. And so we're going to walk you through how this tool works, how we built it, and give you kind of a step-by-step. So first of all, this tool is going to output a map, one map for each state that you want a temple location optimized for. So we, in our case, chose 11 different states, and to get uniformity throughout all those, you need to create a template map. And you do that, and here this is our template map. This is how we want each of our maps to look as their output. So we have a title that's going to be displayed up here, page number down here, our legend, north arrow. And then there's these two layers that you can see showing. One's a state boundary, and one is possible locations. And you can see that's a raster showing up in a neon green. And so this is how we want each of our maps to look. We had to specify this. Over here, we went into the display settings and chose, orange as the outline color with no fill for our state boundary, and we chose this neon green for the raster of possible locations. And so you have to set this all up yourself, create this template file. And with these, you actually need to save each of them as a layer file. So you right-click, go to Save as Layer File for state boundary, also for this possible locations. You'll do the same thing, right-click and Save as a Layer File. And I won't show you that because we already did that, and you just need to make sure that it's stored in a place where you know where to find it. So once you've done all that, you can actually remove these layers out of here. So you just remove those layers out of there, and then you can run the tool. So you go over here to Catalog, and we have it saved in a toolbox. It's called the Temple Locator script. You can see there's 5 different parameters that you as a user have to input. First, you have the data directory. This is going to be a master directory where all of your data is stored. That's your roads data, elevation data, the kind of data representing the existing membership of the church. All that will be stored there, and we'll show you that in a minute, how that's displayed and laid out. Here's these 2 layer template files that determine the display of those layers that I just showed you how to save. This is an output directory, and you can specify wherever you want those PDFs to be created and stored. Then this is your geodatabase, and that's where you want your intermediate data sets stored. So this is what you need to input as a user. I'm going to jump over and show you kind of how this folder, your data directory, needs to be laid out. So this, as your master directory, you're going to have a different folder for each state name that you want to be locating temples in. As I said, we chose 11, so we have all these 11 states. Within each of those, you have to have 3 subfolders. One's boundary, one's population, one's roads. These are 3 of the data sets we're going to use to optimize temple locations. So within each of these, we have a shapefile stored. This is a state boundary shapefile, and this one we have population state file or shapefile. Then we have a road shapefile. So again, you have to have that same layout for each of the states. And then the other necessary directory you need is this DEM directory, which has all of your elevation data, and it has to be a DEM of the entire USA and so yeah, that's going to be your one elevation DEM that's going to be used. And so if you have that layout in your master folder, then it should run correctly. And I'll show you that now. I'll click run, although we're not going to watch it run. I'll just cancel it. So it's going to start running, and it's going to output some maps, which we'll show you here in a moment. I'm going to turn the time over to Jake, and he's going to walk you through the actual code and how we program this to work.
All right, so as you can see here, we have our Python script up on screen. We have our imports right here, which we used. A couple of highlights I'd like to mention is the URL lib2 and the beautiful soup. I'll go into further detail with those in a minute. I would like to just put it out there that our script is actually on GitHub, and so I'm going over this script very surface level. Feel free to check out our script on GitHub for more detail and more detail. So basically what we have here, this block of code is for the user parameters, which Sean showed you earlier in the ArcMap. And then here we have all of our variables which we use for our program. We have our local variables, which are for all of our data sets. They're currently set to empty, and we'll be storing our data within those variables. We also have our map variables, and then we have our intermediate variables, which will store our intermediate data sets. And so basically what our program is going to do is it's going to open up your master directory that has all of your state folders saved in there, and it's going to loop through all of those, open up all of our data sets, and then run and manipulate that data in our geoprocessing section of the code. So we're going to first get rid of any PDFs that are existing in there, just so that there's no confusion with our program, and then we'll create a new empty PDF for you to store all of your files in. The highlight of our code is this section right here, where we use our URL-lib2 library and our beautiful soup library. And basically the URL-lib2 is going to open up that URL which our stake center data is, or our addresses are stored in, and then the beautiful soup will be able to read through that HTML which is associated with that site and pick out where tags are at, which has the stake center addresses associated with it, which we can then store and save in a list, which we will then loop through and perform some geocoding through the beautiful soup, which will convert those addresses into latitudes and longitudes, which we will store in here, and then we will then convert those into a point shape file, which we will then import into our map to use. And so once we have that part done, we're then going to go in and upload all of our data for our population, roads, and state boundary into our map so that we can perform our geoprocessing. And this large section of code from here on down is going to be our geoprocessing section. Basically what we're going to be doing is we're going to be creating a bunch of buffers and intersects with all of our different data sets together, which we will then use to pick out our ideal temple locations. So just to quickly tell you some of the requirements which we thought of for those buffers and intersects. We chose to use a population density of 1,000 people per square mile, which is actually right here in this part of the code. Once we did that, I guess I should also mention the fact that our population data is stored not as a raster, but actually as polygons. And so what we did here in this section is after we specified what we wanted our density to be, and we created fields in the attribute table for that, we then combined those polygons into larger polygons which fit our criteria. So we also wanted our DEM slope to be less than 15 degrees. We figured if you're building on a really steep slope, that wouldn't be really great, structurally speaking. So we specified that right there. And we also wanted a 5-mile buffer around our stake centers. We wanted a 1-mile buffer around our population polygons. And we also wanted a 2-mile buffer up here for our roads. So with those buffers, we are going to then intersect all of them together and then reclassify, or I guess I should say we're going to convert that into a raster and then reclassify it. So in this step right here, we convert all of those shape files into a raster file, and then we then reclassify it. We basically want everything within those intersects, and so this step right here, this greater than specification, we basically say anything that has a value greater than 0, which is everything, we want to keep. So we'll keep that, and then we will take that DEM, which we had up above, and multiply that raster to our new raster, which the raster of the intersects, to eliminate areas that have slopes greater than 15 degrees. And the result of that is our possible locations, and which we get here and we save that. We're going to store that in to that layer which we have previously set up. And so then the rest of this right here, this piece of the code, we're going to add these layers then to our map. We're going to zoom in to where our state boundary is, so that we're not, or I guess so that we can be able to see where those temple locations are easier. And then this right here, this little bit of code is going to allow us to get our symbols for, or I should say symbol for our state boundary, and then this will update the symbology there on the map. And again, with this piece of code right here, same type of thing, except we will do that with our possible locations. So it will get that symbology for the possible locations and then update that on our map. So now we have this little chunk of code which will change the text size and the titles for our map, print that to a PDF, and then it will refresh that view for you. Right here we have a little loop. It's an empty loop, and it basically is just allowing the program to run and prevent it from freezing. And so at the end here, as we move down just a little bit, we can restore our text to its default setting in the PDF template, and then we can remove layers from the previous map so that we don't get overloaded with layers, and then it'll save and close your PDF. And right here at the very end, we have this try-catch bit of code, which actually starts, let me scroll up here to the top. Right here. And basically what this is going to do is it's going to prevent the user from crashing the program due to perhaps they select a file path that doesn't exist. And so instead of crashing the program, it'll actually run through this entire bit of code all the way down here to the very end, and it will show a message saying that the path does not exist, and to please check that file path and retry. And so that way you don't have to restart your ArcMap again, and you can try that again. And then once everything is completed, then you'll have a little message pop up that says the script is finished. And so Sean is actually going to walk us through our product from the script.
Alright, I'll just show you the final product. So this is a master PDF, and here we have a title, temple location for Arkansas, and we see that symbology I talked about. We have the neon representing the possible location, the neon green, and then the orange boundary of the state. And as we scroll through, we'll see now we have one for Delaware. Same thing. These are possible locations, state boundary, and Iowa, and so forth. So that script runs in about an hour. It goes through all that code Jake demoed for you, and in an hour you have these beautiful maps, and you can know the best locations for temples in 11 different states, or however many you want. And that is all. Thank you. Check out the code on GitHub, and we'll take care.